Hi, we're going to be looking at some conservation of momentum with a couple of questions here. We're looking at a couple of sticky type collisions. That's where two objects will collide and they'll stick together and then move off afterwards. So the first one of these is a railway truck of mass 10 tonne and moving at 6 metres per second collides with a stationary railway truck of 5 tonnes. They join together in the collision and move off as one. Calculate the speed of the two railway trucks as they move off. If you need to, you can draw little diagrams to represent what's going on with them. So we've got a 10 tonne truck which is moving at 6 metres per second, and it collides with a stationary truck of 5 tonne, and then the two of them join together, move off at some velocity. So in order to work this out, conservation of momentum, we need to look at the total momentum before as being equal to the total momentum after the collision. So the initial momentum and the final momentum. So I'll have mass 1 times by velocity 1 initially, plus mass 2 times by velocity 2 initially, will be equal to mass 1 plus mass 2 multiplied by the final velocity. So momentum is equal to mass times velocity, so we're just looking at the individual components here. So mass 1 is 10 tonnes or 10,000 kilograms times by its velocity of 6 plus mass 2 of 5,000 kilograms times by its velocity of 0 will be equal to the combined masses of them, which is going to be 15,000 kilograms times by the final velocity. Now if we calculate the left hand side, the 5,000 times 0 is just going to be 0. We don't need to worry about that. So we're going to have 60,000 is equal to 15,000 times by the final velocity, and what we now need to do is divide both sides by that 15,000 to get the velocity on its own. Divide that by 15,000, that will cancel that down, and that will leave us with our final velocity being equal to 60 divided by 15 is 4 metres per second. So the answer to this one is 4 metres per second. In this case here, they'll be moving off to the right or in the same direction as the initial 10 tonne railway truck. If we're talking velocity, we do need to have a direction. Sometimes the direction can be as simple as a positive or a negative number. So we've got a positive here, or if we're looking at the diagrams, the final velocity would be to the right. Now calculate the change of momentum of the 10 tonne truck. Quite often with these momentum questions we'll talk about a speed and then a momentum, and then the third part is the impulse, but we'll deal with the change of momentum first. So change in momentum is equal to the final momentum less the initial momentum. It's also equal to the mass times the change in velocity, and change in velocity is mass times by the final velocity less the initial velocity. So in our case we're just looking at the 10 tonne truck, we're not looking at the whole system. So our change of momentum will be equal to the mass of 10 tonnes or 10,000 kilograms multiplied by the final velocity was 4 metres per second less the initial velocity of 6 metres per second, which will be equal to negative 20,000 kilogram meters per second. Or that would be a momentum change to the left. And for the third part of this, what impulse did the 10-tonne truck exert on the 5-tonne truck? We've got a direction implied within the question, so we just need to look at the magnitude of the value. And change in momentum is equal to impulse. So our answer is going to be 20,000. The units are the same, but it's preferable with impulse to have units of Newton seconds. So the answer to that third part is 20,000 Newton seconds. Let's move on to another question. Jenny is having an early morning target practice session on a very chilly day. She finds an iced over tree stump. Picturing it must be pretty cold for the tree stump to be iced over, but anyway, that'll be there because we need to get rid of friction. She finds an iced over tree stump at the range and places a 9 kilogram block of wood on it. She then goes back and fires a shot from her pistol. The 30-gram bullet lodges in the block of wood, so it sticks in together. The bullet sticks with the wood, so they move off together, and it slides over the surface of the tree stump. If the bullet was travelling at 301 metres per second, how fast does the block of wood move after impact? So we go through the same process. Sum of the momentums initially will be equal to the sum of the momentums afterwards, or final. So we can have the mass of the bullet multiplied by the velocity of the bullet plus the mass of the wood, and the velocity of the wood will be equal to, now they join together, so we join the masses, the mass of the bullet plus the mass of the wood multiplied by the final velocity. Now if we substitute some values in, we've got the mass of the bullet is 30 grams, which is equal to 0.03 kilograms. I need to work in kilograms. So I have 0.03 times by the velocity of the bullet, which is 301, plus the mass of the wood, which is 9 kilograms, times by its initial velocity, which is 0, is equal to the combined mass. The bullet plus the wood will be 9.03 kilograms multiplied by the final velocity with which they move. Now again, we calculate the left hand side. We've got 9 times 0, which is just nothing. And then we have 0.03 times by 301. It gives us an answer of 9.03. And that will be equal to 9.03 V by the final velocity. And it's not always going to be that convenient that the numbers work out, but often in calculations they will nicely work out, so we're going to divide both sides by 9.03. That will cancel that down to leave us with one lot of velocity, and on the left hand side they will cancel down to leave us with 1, so that gives us an answer of our final velocity of the block with the bullet lodged in it, moving off at 1 metre per second. Now for the second part of this question, what is the change in momentum of the block of wood? So we only need to be dealing with the block of wood. So the change in momentum is equal to the final momentum less the initial momentum, which is equal to the mass times the change in, I'll rub that out, get the wrong symbol, mass times by the change in velocity, which is equal to the mass multiplied by the final velocity less the initial velocity. In this case here, we're looking with the block of wood, so it's going to be 9 kilograms multiplied by the final velocity was 1 metre per second and its initial velocity was 0. So that will be equal to 9 times 1, which is 9 kilograms metre per second. And if you remember from the last question, that's also equal to the impulse. Okay, in the next of these questions that we'll look at, we have two 5-tonne train carriages rolling freely along a section of track in a shunting yard. One travelling at 10 metres per second north collides with another which is travelling at 5 metres per second north. They couple together on impact and continue moving north at what speed? So this is a variation of the questions where we have two trucks. They're both travelling in the same direction, so instead of one being still, they're actually both travelling. One of them is travelling at 10 metres per second. It's metres per second, that should read. And the other's travelling at 5 metres per second. Okay, so they do collide together, but we have the same approach with this. We have the sum of the momentums at the start will be equal to the sum of the momentums afterwards. If we call this one truck 1 and truck 2, we have M1V1 plus M2V2 is equal to M1 plus M2 added together, multiplied by the final velocity. And we have two trucks which are 5 tonnes or 5,000 kilograms each. So 5,000 times by 10 plus 5,000 times by 5 is equal to 5,000 plus 5,000 times by the final velocity. 5,000 times 10 is 50,000. Plus 25,000 will be equal to, the mass of the two of them combined is 10,000 multiplied by the final velocity. So on the left hand side here we have 50,000 plus 25,000 is 75,000 is equal to 10,000 by the final velocity. Now what we need to do is divide both sides by 10,000. That cancels that down, and that leaves us with our final velocity being equal to 7.5 metres per second. And the question has stated that they continue to move north, so it's already given us a direction. So our final velocity is 7.5 metres per second north. That's the answer to that one. And let's move on to one more question. Here we have a student conducting an air track experiment. The experiment sees a 100 gram cart moving to the right at 5 metres per second and colliding with a 150 gram cart moving to the left at 3 metres per second. Velcro ensures that they stick together, and what is the combined velocity after the collision? So here we have two carts which are actually moving in opposite directions. So we have 100 grams, and that's moving at 5 metres per second. And the other one is 150 grams, moving at 3 metres per second. As I said, the directions are opposite. So what we need to do is, at the start of this, we're going to take to the right as positive. So what that now means is that for the second cut, it's going to have a velocity for the second cut of -3 meters per second, because it's moving to the left. Then we go through the same process again. The sum of the momentums before will be equal to the sum of the momentums after, or initial and final. And I'm going to call this one cart 1 and cart 2. So M1 V1 plus M2 V2 will be equal to, they stick together, so M1 plus M2 multiplied by the final velocity. We have 100 grams is 0.1 of a kilogram times by 5 plus M2 is 150 grams, or 0.15 of a kilogram times by, and it's moving backwards, or -3 meters per second. Okay, that'll be equal to M1 plus M2, so 100 plus 150, or 0.1 plus 0.15, do it in kilograms, multiplied by the final velocity. Okay, let's work a few of these things out. 0.1 times 5 is 0.5, plus 0.15 times -3 is -0.45. And that will be equal to 0.25 times by the final velocity. Working out the left-hand side here, 0.5 plus a -0.45 is the same as taking away 0.45, so we end up with 0.05 is equal to 0.25 by the final velocity. We're now going to divide both sides by 0.25, and that will give us a final velocity of positive 0.2. Now, because it's positive 0.2, we said at the start we're taking to the right as positive, so that'll tell us that our final velocity is equal to 0.2 meters per second to the right. Now, I hope you find those questions useful.